Why are black hole singularities so hard to imagine? Imagine a place in space so dense that it crushes everything into an infinitely tiny point. That's what a black hole singularity is. But trying to picture it is a real challenge. First, singularities happen at the very edge of what physics can explain. They are points where density becomes infinite, and our usual laws of physics just stop working. Our math equations break down, so we can't predict what happens there. This makes it impossible to truly understand or visualize what a singularity looks like. Second, our brains are wired to understand objects with size, shape, and position. A singularity defies all of that. It is a point with zero volume but infinite density. It's like trying to picture a point that is infinitely packed with matter. Nothing in everyday life comes close to this idea, so it's hard for us to imagine. Third, the gravity near a singularity is so extreme that it warps space and time in strange ways. As you get closer to a black hole's center, time appears to slow down from your perspective. To someone far away, you seem to freeze at the edge of the black hole. Space itself becomes so distorted that all directions seem to point inward. Once you cross the boundary called the event horizon, escape becomes impossible. These effects are very different from what we experience daily and are tough to picture. Fourth, we cannot see singularities directly. The event horizon, which is the boundary around a black hole, blocks our view of what's inside. Light cannot escape from beyond this point, so we can only observe the effects of black holes from outside. This means we relying on mathematical models and theories, not actual images, to understand what's happening deep inside. Fifth, some scientists question if singularities even exist in reality. They suggest that quantum physics might prevent true singularities from forming. If that's true, then what we imagine as a singularity might not be real at all. This uncertainty makes it even harder to picture something that might not exist in the way we think. Scientists use computer simulations to help us visualize what falling into a black hole might look like. These show how light bends and how the sky appears warped as you approach the event horizon. While these images can't show the singularity itself, they help us understand the extreme effects near black holes. All these reasons add up to why singularities are so difficult to imagine. They mark a boundary where our understanding ends, they defy our everyday sense of space and time, and they are hidden from direct view. Yet, they remain as a key part of understanding the universe's most mysterious objects. That's why scientists keep working to learn more about them, even if they seem impossible to fully picture.